From the other day's assignment, we worked on just one-step equations, and we did both adding and subtracting, and then we did multiplying and dividing ones. So here's some examples that we used in class. X equals 2 plus 5, that's just x equals 7. Now for all of these, you have to show your work. So x plus 5 equals 10. You have to show how you worked it out. So right underneath it, you have to subtract the 5 from each side. So then x, that becomes 0, equals 5. This whole thing is kind of like a balance where you put the weights on. If you take something away from this side, it goes out of balance. You have to take the exact same thing from the other side. So you always have to take the same thing from one side and then the other side. Another example would be x minus negative 3 equals 2. First step that I'm going to do is I need to do that minus a negative. I need to turn it to a positive. I'm going to rewrite it. It says x plus 3 equals 2. I have to do the opposite function to get rid of that 3. I need to isolate the variable. Let's get that by itself. So I take 3 away from this side, and that's going to be 0. Then I have to take 3 away from the other side, so that cancels. 2 minus 3 is going to be negative 1, and that would be the answer. And this is how you show your work. This can happen with fractions also, and it can be in the opposite order. So 3/4 equals x plus 1/2. I need to get rid of this 1/2, and to do that, since it's an x plus 1/2, I'm going to subtract 1/2 from this side. I subtract 1/2 from this side, and that's showing my work. And then 3/4 minus 1/2 would be 3/4 minus 2/4, which gives me 1/4, and that equals x. They'll throw some with absolute value at you. So the absolute value of negative 3 plus y equals 12. Well, I'm going to first have to get rid of this absolute value of negative 3. I know that's 3. I just rewrite 3 plus y equals 12. I need to get the y by itself. That's isolating the variable. So I need to get rid of this 3. I subtract the 3, and that cancels out. So I get y equals 9. And that's how you show your work. Another would be 17 minus negative y equals 25. Again, there's 2, there's a minus a negative, that becomes positive. Adding positive, I'll rewrite 17 plus y equals 25. I need to get rid of this 17. To isolate the variable, subtract 17, I get y equals 8. These show up. Negative b equals 10. So if I have negative b equals 10, what does b equal? Well, this means the opposite of b. And if negative b is 10, the opposite of that is going to be negative 10. Or you can just multiply it by negative 1. Because negative 1 times negative b is b, so then you have to multiply this side by negative 1, and then that gets negative 10. If you know negative b equals 12, b is going to be negative 12. If negative c equals negative 13, then c equals 13. So an example like that would be 3 minus a equals 0. I have to get rid of this 3. So I subtract 3 from each side. And even though there's not a sign in front of it, to add or subtract, we know that positive 3, to get rid of a positive 3, you just have to subtract 3 or take the negative 3. That cancels out. I get negative a equals negative 3, because 0 minus 3 is negative 3. And then since they're both there, a equals 3. For multiplication, It's a little bit different, but not too bad. You do have to take the opposite function. So if I have 3x equals 15, I need to get x by itself, and I am going to have to get rid of that 3 times x. And how I need to do is I need to get it to 1 because that's the identity property of multiplication. So I'm going to divide it by 3. That becomes 1, and 1 times x is x. 1 times any number is x. 1 times any number is a number. So x equals 5. 3 times 5 is 15. So that works out. So another one like that is 2x equals 10. Divide each side by 2. I get x equals 5. You can also have multiple or division ones, and you have to get rid of that division. So z over 5 equals 2. I need to get rid of this divide by 5. So I'm going to actually multiply it by 5, because 5 divided by 5 is 1. So it gives me the z by itself. And if I multiply this side by 5, I can multiply this side by 5. And I'm in balance, and z equals 10. X over 3, x over negative 3 equals 1/3. So to get rid of that, I need to do the multiply it by negative 3, because this is divided by negative 3. I'm going to multiply this side by negative 3. That's going to cancel out and become 1. But then I have to multiply this side by negative 3. And I get x equals negative 3 over 3, which is negative 1. Sometimes we'll have fractions like 2/3 x equals 1/2. Now I need to get rid of this 2/3 in front of this x. What I've done up here is I've divided by the number. So 5 divided by 5 gives me 1. So I'd have to take 2/3 divided by 2/3. And that looks weird because they're both on top of each other. So instead of doing it that way, I'm actually going to multiply it by, or divide 2/3 divided by 2/3. But dividing's annoying, so we don't do that. So then I have to take 2/3 x times, and I'm going to change, flip, and this becomes 3/2. So 2/3 divided by 2/3 is the same as 2/3 times 3/2. And that's just 6/6. They kind of cancel each other out. And since I multiplied that side by 3/2, I have to multiply this side by 3/2, and I get 3/4, and that's my answer. If you see one like this, it's kind of the same thing. Negative 1/5 y equals negative 6. I need to get rid of that, and I know a negative times a negative is going to be positive, so what I multiply by has to be negative, and I'm just going to do this division, so it ends up flipping that over. And so it's negative 5 over 1. That's negative times a negative. It's going to be positive. So that's fine. That's canceled out. And then I have to multiply this side by negative 5 over 1. I'll put this 6 over 1. I get 30 over 1, which is 30. And that's the right answer. Negative 2/3 t equals negative 16. So I'm going to have to get rid of that negative 2/3. I'm going to multiply it by negative 3/2. Those cancel out. Then I have to multiply this side by negative 3/2. And I'm going to get, that's 48/2. And that becomes 24. For these assignments, you have to show all your work. So if you have 3 halves x equals 10, you'll have to show your work. And then probably across the table or across the page that you have, then you would do each of the ones. And showing your work, each one. And it's z equals 20. And some people were writing them 3 in a row on the top of their pages. And I knew a couple people who did 4 across the page. I did 2 across my page. So as long as it's neat enough and you can see it, now get to that Canvas assignment 3.1 and 3.2.